Good evening, everyone. It's a pleasure to be with you today. My name is Rob Stone, Vice President, Corporate Development and Communications with Metamaterials, Inc. Before we get started, I need to advise you that this presentation contains forward-looking statements and are subject to risks and uncertainties, so that actual results may vary from our forward-looking statements today. Investors are encouraged to consult the risk factors in our various filings with the SEC, and all references to money amounts in today's presentation, unless otherwise noted, are in US dollars. So what does Meta do? Meta delivers breakthrough performance across a range of applications and industries by designing, developing, and manufacturing sustainable, highly functional materials. We make metamaterials, and metamaterials exhibit properties which go beyond those that are found in nature and are used to manipulate and manage light, heat, radio waves, and other forms of energy. And you might be wondering what this all has to do with the blue butterfly that you see up there on top. Metamaterials and the science of metamaterials are actually inspired by nature because the blue color that you see on the butterfly's wings doesn't come from pigment. It's actually resulting from the nanostructure of the insect's wings and the way those tiny structures interact with light. Meta has three key advantages: speed, scale, and cost. Our system is based on software aided by machine learning and artificial intelligence, and that allows us to design a library of new patterns for different applications. Typically, in a matter of hours or days, we can come up with new designs and samples for our customer, instead of a process which, using traditional chemistry, might take months or even years. The second point is that metamaterials have been understood in the laboratory at a tiny scale for decades. What's fundamentally different about Meta is that we are producing roll-to-roll metamaterials on proprietary production equipment on large area, high volumes, and repeatedly. So we're producing metamaterials at scale. And what that leads to is falling costs. As the width of our substrate increases and the speed of the line increases, the cost per square meter will fall. And as the cost per square meter drops, that enables a wider and wider served addressable market for Meta. Now, what is our market? Our market opportunity is quite diverse because of the range of applications that we're developing, and it's driven by a number of mega trends. Two noteworthy ones are 5G infrastructure and vehicle electrification. 5G networks represent huge investments in order to deliver broadband speeds wirelessly, and Meta has solutions to do that more economically, faster, more sustainably, and in a more aesthetic way. In vehicle electrification, we also have solutions that will increase the efficiency and enhance the safety of electric vehicles. There are lots of other markets, medical, energy, aerospace, and so on. The chart you see on the right is one estimate of just metamaterials at the component level from Lux Research, where it gets to almost $11 billion by 2030. Another key point to make about metamaterials is that we're all about doing more with less. Today, supply chains are a problem globally, and the scarcity of raw materials is a key concern, especially for fast-growing markets like battery materials for electric vehicles. Much of the capacity that will be needed over the next decade to address the demand for these markets doesn't even exist today, not just at the factory level, but at the component level and even the raw material level. When we talk about transparent conductive films, Meta has a replacement using common materials like copper or silver for the most prevalent transparent conductive film, indium tin oxide, or ITO, which is a scarce material and the supply of which is heavily concentrated in Asia. Meta is a technology platform company. And by that, we mean we have broadly applicable technologies that allow us to address multiple markets, and our platform keeps getting broader. We began our business, our first product, using holography. That technology involves recording with a laser into a photosensitive material, photopolymer, to produce holographic gratings. Our first product was Meta Air, the laser glare protection eyewear for pilots that we jointly developed with Airbus. In holography, we're also developing heads-up displays that can be used for automotive and aerospace applications. The second pillar of our platform is lithography, where we have another proprietary system, rolling mass lithography, RML for short. This allows us to produce a sub-micron metal mesh, you can see pictured there, which we call Nanoweb. And Nanoweb has a host of applications in transparent antennas and reflectors, EMI shielding, and transparent heaters for de-icing and defogging. Last year, when we acquired Nanotech Security Corporation, we also added in-house capabilities in electron beam lithography and nano-imprint lithography, together with roll-to-roll processing that allow us to produce nano-optic security features for banknotes and government documents and brand protection, and we do that with nanometer accuracy across kilometers of output. Wireless sensing is the key foundation for our medical applications, which are used to enhance signals and images for medical diagnostic applications. Pictured here, you can see a rendering of GlucoWise, which is a non-invasive glucose monitor, which we are developing using wireless sensing. And finally, on the right, you can see as we're trending towards higher levels of integration for our platform, AR Fusion is a system which allows the production of prescription lenses for augmented reality eyewear, embedding all sorts of smart technology within a prescription lens. And plasma fusion is another platform technology we recently acquired, which allows the high-speed coating of any solid material on any substrate. And I'll have a lot more to say about plasma fusion a little later on. Meta is truly a global company. Today, we have offices around the world. Two of the newest locations are in Athens, Greece, and Maryland in the USA. By locating in these various places, we're able to access pools of talent, as well as key customers and support from various government agencies, which we've enjoyed historically from Canada and the UK, and which we'll be seeking from the Greek and EU governments in our new Athens office. Athens is also one of 5 centers of excellence for 5G infrastructure in Europe. Our newest location, where we're going to be opening an office soon, is in Maryland, USA, which gives us proximity to many aerospace and defense companies, as well as government agencies, and of course, the US Capitol. So let me give you an update on nano-optic security products. Last year, as I mentioned, we acquired Nanotech Security Corp, which produces security features for banknotes and government documents, as well as protection for brands. The benefits of this technology are twofold. We got this proprietary technology in the 2 markets that it serves, as well as another list of potential markets that you can see here. It also allowed us to jumpstart our manufacturing scale up, bringing in-house e-beam lithography, nano-imprint lithography, a range of other manufacturing technologies, but even more important, a team with decades of experience in roll-to-roll production, already producing kilometers of material. Now, pictured on the upper right of this slide, you can see a banknote with color optic stripe. This is a proprietary new security feature, which is recently featured in the Banknote Technology Report version 8. When you examine a banknote with this stripe under any normal lighting conditions, you see colors, motion, and 3D depth. It's a unique security feature that's virtually impossible to copy. Now, just before we acquired Nanotech last year, they announced a new frame agreement with a confidential central bank for whom we are developing a new security feature for a future banknote. That agreement, as of last year, was $41.5 million over a period of up to 5 years. And we started fiscal 22 with $7 million of purchase orders from that customer under the frame agreement. Last month, we announced $2.2 million in new orders from the central bank customer, including $1.2 million for sample product, bringing total bookings for this year to $9.2 million. The roadmap for this effort is for us to win the selection for the first banknote for this flagship customer, then expand hopefully to other denominations with that central bank and follow on business with other central banks. This is an overhead view of a facility which we acquired as part of the purchase of Nanotech. We paid $66 million net of cash acquired for Nanotech and all of its IP and facilities. Part of that purchase was this 105,000 square foot facility on 11 acres of land, which is owned by Meta today. About 35,000 square feet, so roughly a third of this facility is used for production today. We are expanding production space here in preparation for doubling our nano-optic security capacity to 15 million square meters per year. We already have the capability for 7.5. In addition, we're adding space reserved for the next generation of our Nanoweb roll-to-roll line, which will increase the web width from 300 millimeters to 500 millimeters. A final point to make about locating production in Thurso, Quebec. This location is served by Hydro-Quebec, which is hydropower, and that gives us a clean, renewable source of low-cost energy so that we can grow our production sustainably. Another platform technology which we acquired last year is AR Fusion. We acquired the assets and IP of a Swiss company, Interglass, which developed an automated lens casting system for producing prescription lenses on demand using less energy and less material than traditional ground lens blanks. What we add to the prescription lens is a variety of smart technologies embedded within the lens that could include things like a holographic display, autochromic dimming, defogging of the lenses, which is a problem these days, especially if you're wearing a mask. And that can be enabled by our Nanoweb technology. We have 2 complete AR Fusion lines up and running at our Halifax facility now, in preparation for supplying these lenses to OEMs who want to make AR eyewear. As part of this effort in January, we also joined the LASAR Alliance, laser scanning for augmented reality, which is part of the IEEE standards organization. Now, I mentioned Nanoweb several times. Let me say something more about a very important milestone that we recently reached in early this year. We installed, first of its kind, anywhere in the world, a roll-to-roll 300 millimeter wide system to manufacture Nanoweb. And on the top right, you see the RML system where the patterns for Nanoweb are transferred by UV light onto the photosensitive material on the film. Now, the process steps for making Nanoweb were already proven on Meta's established wafer scale line, but a key test for this new manufacturing system, first of its kind in the world, was to see if the output would match the performance of the golden sample on the wafer line. One of the first applications that we're producing with this roll-to-roll line is for 5G reflector film used for 5G infrastructure with our partner Sekisui Chemical of Japan. I'm pleased to tell you that the first sample of 5G reflector film, which we produced with the new roll-to-roll line, demonstrated performance that was in 1% of the performance of the golden samples from the wafer line, which are equal to the performance of a solid aluminum plate in reflecting 5G signals. But of course, you can't see through an aluminum plate, so you wouldn't want to put that on the window of your building. We already understand the small anomalies, which lead to the 1% difference. And we expect to be making golden sample product off the roll-to-roll line soon. Meanwhile, Sekisui is continuing to do market development for this application. They recently published indoor propagation measurements using samples that we've already provided, and we expect increased shipments to Sekisui in the second half of this year. Another recent milestone is that internally, we demonstrated transparent microwave oven doors using Nanoweb. So we can reflect and guide a 5G signal. We can also block electromagnetic radiation just by changing the pattern. In both cases, the film is transparent to the human eye. So while your food is cooking, you can see through a perfectly clear door on the oven and see what's going on inside. We're looking forward to building a number of these demonstration units and sending them to various OEMs for their own internal testing. Our testing of a microwave equipped in this manner showed that it actually leaked less measurable radiation from the microwaves than the original equipment microwave that we took apart to add our transparent door. Scaling up Nanoweb to roll production is critically important, as I mentioned before, in addressing a larger and larger served addressable market. As we get higher volume and larger area Nanoweb capacity, it will enable a whole range of new applications. One of those is de-icing and defogging of windshields, windows, mirrors, headlights, and sensors for electric vehicles, and we're in discussion with numerous OEMs for that application. Now, I mentioned Plasma App as one of our Plasma Fusion as one of our new platform technologies. In early April, we acquired a UK company, Plasma App Limited, which has invented proprietary high-speed coating. It's in a vacuum, any solid material on any substrate. The gentleman you see in this picture is Dmitry Yarmolych, who is the founder and CEO and joined us as the vice president for our Plasma Fusion technologies. Back in 2014, when he founded the company, working alone in just 6 months, he came up with the first working prototype for this technology. Plasma Fusion has a wide range of possible applications, including batteries, semiconductors, printed circuit boards, and protective and optical coatings. In battery materials, for instance, there's the potential for millions and millions of meters of output. It's roughly a $40 billion market based on various analyst estimates we've seen. We expect to use large-scale metallization based on plasma fusion to increase the efficiency of our nanoweb production, as well as our color optic films for nano-optic security, leveraging our CapEx to get more output for the same line of equipment. And we also will make this technology available for sale and licensing to others. In the pictures below the large picture, you can see this technology is able to use 2 sources at the same time, so it can layer or blend different materials. And it's also able to fuse the deposited material onto the substrate in combinations that you wouldn't otherwise expect. For example, plasma fusion is able to coat and adhere copper onto ceramic substrates and even onto Teflon. A key part of Meta's strategy is intellectual property. We're building a very large patent portfolio, not with the expectation that we would trade patents with others, but as a moat around our market so that we can continue to enjoy strong margins for our investors and maintain our proprietary advantage. As of the Q1 report, which was a week or so ago, we had 302 active utility and design patent documents. 175 of those are issued, including 1 design patent. In the United States, we have 38 issued patents and 30 pending applications in the US. And elsewhere around the world, we have 137 issued patents and 97 pending applications in 24 other countries. I mentioned that our portfolio is growing fast. To put some perspective on that, last year in August, when we reported our Q2 results, we had 149 active patent documents. It's more than doubled in less than a year since then, under the leadership of our new Chief Intellectual Property Officer, Shan Kerner, who joined us last year in September. I want to mention specifically one very recently issued patent. We had a press release about that just last week, which is the first US patent for our non-invasive glucose monitoring system known as GlucoWise. I mentioned briefly on the technology platform slide. This foundational US patent covers the film, metamaterial films, and various configurations of the system for reading biomarkers on different parts of the body. It covers the metamaterial anti-reflective film, which enhances signal penetration through the skin, and it covers the dual sensors, radio wave and optical, that are used to measure the signals that are transmitted through the tissue. The roadmap for this device is to produce first a tabletop device, like you see pictured on the bottom of this slide, followed by a portable and eventually a wearable device. The woman you see in the picture here is Dr. Helena Cano Garcia. She is the lead inventor on this patent and a longtime Meta employee. Meta has a wide range of market applications which we're beginning to commercialize in different verticals. And in order to capitalize on all the opportunities we see in front of us, we're building a world-class organization, including bringing in executives with decades of experience at much larger organizations. Last month, we announced 2 key additions to the executive team, who you can see pictured here. George Francis, our new Chief Information Officer, has over 25 years of experience in a range of sectors. He has led the design and implementation of IT architecture systems and cybersecurity elsewhere, and he'll be doing that for Meta, also helping us address our global regulatory and compliance needs, and providing insights into the potential to monetize some of the data that will be generated by our emerging products, especially in the medical field. Dr. John Yanis Antionadis joined as EV Head of Engineering and Electro-Optical and Infrared Systems. Yanni has over 35 years of experience in system, hardware, and software development of advanced technology systems, and he's a demonstrated leader in both academic, government, and the private sectors. Meta has for several years been very good at developing new breakthrough technologies in the lab. We're now at an inflection point where we're commercializing these technologies, and Yanni will be building a team to drive product engineering and increasing vertical integration of Meta's technology portfolio. He's also located in Maryland and will be heading up the new office there. So let me mention briefly a few highlights from our first fiscal quarter. Revenue grew 399% year over year to just under $3 million. The bulk of this revenue comes from development contracts, including our development contract with the large central bank customer. We expect development revenue to continue to be a majority of our revenue going forward, but product revenue will make an increasing contribution as we go through this year and into next year. We finished the quarter with $30.2 million in cash and cash equivalents, including a small amount of restricted cash. Meta has no debt except for about $3.3 million in no interest loans from the Atlantic Canada Opportunities Agency. In the first quarter, we reported a net loss of $18.4 million. Included in that loss were about $6.2 million in non-cash expenses. So on a cash basis, operating expenses in the first quarter were in the neighborhood of $12 million. So let me just summarize and leave some time for questions. Meta is a company, a category creating company, the first metamaterials company listed on the NASDAQ. And we are leading the inflection point in the industry where metamaterials come out of the lab and begin to be produced at scale. We've assembled a team of multinational subject matter experts. with a company of approximately 150 people, almost 40% of our employees are PhDs. I mentioned our broad and growing intellectual property estate, our software-driven design and simulation tools, and our proprietary production platform. Every product that Meta has on offer today is covered by at least one issued patent, either in the products or in the technology that's used to manufacture it. We're establishing global partnerships with OEM and Fortune 500 companies, and we have access have had in the past and expect to have continuing in the future access to non-dilutive government funding to help augment our own cash position. And with that, I'm happy to take your questions.
All right, Rob, thank you very much for the presentation. That was very well done, and it gave, I think, investors a very good overview of what you're doing, and especially new project and development and where you guys are heading. We got a few questions in, and we have 13 minutes, so plenty of time to answer them. Jeff asked, who would be target? Yes, you can take a sip or two, no problem. Take your time to build back the voice. Yeah. Who would be target customers for Plasma app? And the following comment is, Meta seems very diversified and vertically integrated.
Okay, so Meta is a business-to-business company. So we're typically going to be producing a component or a subsystem within some other company's product. And we're seeking to partner with and are partnering with leading OEMs in each of the various sectors that we're in. Now, the medical products are something of an exception in that regard, because we are producing with GlucoWise, for instance, a complete system that will be accompanied by software and related services. But we would still be seeking OEM channel partners, people already active in diabetes management, for instance, to help us bring such a product to market. Now, back to Plasma app specifically, this technology, we expect to focus initially on improving our own internal production capacity and capabilities. So the deposition of metal in particular is important to the production of Nanoweb, and also the nano-optic security films. And upgrading the equipment that we have today and designing new equipment around plasma fusion will allow us to get faster line speed, faster deposition, and higher output for the same amount of CapEx. So lifting our internal capabilities is the first step. That said, Plasma app has already done research work in developing things like battery materials. The current collectors that are used in lithium-ion batteries are composed of copper and aluminum metal foils, essentially a solid metal foil similar to the aluminum foil you might have in your kitchen, but a higher purity and tighter specification. The copper is of particular interest because it's expensive and it's heavy. And Plasma app has developed copper current collectors where they deposited the copper using plasma fusion on both sides of a thin plastic membrane, greatly reducing the weight of the current collector as well as the cost, and importantly, reducing the weight of the battery. As you may know, on an electric vehicle, anything that adds to the weight of the car is going to reduce the range. Anything that makes a battery with the same capacity weigh less, conversely, increases your range. So we see internal applications immediately and a range of interesting applications through equipment or end product OEM relationships in those areas like batteries, printed circuit boards, and semiconductors and so on.
Great, thank you for the answer. Doug is asking, how is the production going at the Pleaston, California facility?
So, excellent question. And Doug is right to be keeping an eye on the scale up of Nanoweb, because that's absolutely the critical path for us. The sooner we're able to scale up the first 300 millimeter pilot scale production line and be satisfied with the output there, the faster we can proceed with the next generation, which we'll be putting in our Thurso facility, going from 300 millimeters to 500 millimeters. Now, as noted, we just installed that equipment early this year. We were optimizing the line for a period of some weeks, and then we recently began producing the first samples. So what we've had to say about that so far is what we said on the Q1 webcast, which is that the first article, which was designed for the 5G reflector project, was 99 versus 100% of the desired performance. That means we're not quite there yet, but that's a whole lot better than saying, well, we're making samples, but they're not close to the design specification. So that was a major milestone. Once you have the recipe right, so you're getting the desired performance characteristics, then the focus would be on things to increase the throughput of the line, reduce the material costs, essentially get higher output and reduce costs. And we will, of course, have something more to say about that each quarter as we go by.
Absolutely. And Doug is following up with is there an update on the construction?
Construction. Okay. We have construction going on in a few different places. So let me just go. I'm not sure which one he's asking about, but let me go through the list. I didn't mention Meta's new 68,000 in my prepared remarks. Meta's new 68,000 square foot headquarters facility in Highfield Park in Dartmouth, Nova Scotia. That is under construction, and we expect to move into that facility so later in the summertime. That's going to be really helpful to us because we've outgrown the incubator facility at One Research Drive. We can't fit any more people into that location, and we've moved into a couple of different satellite locations with part of our operation nearby to Research Drive and finance and admin people in a different spot in Dartmouth. So it will be fantastic to get everyone under one roof and have a showcase customer training center where we can bring existing and prospective customers later this year in Halifax. As mentioned, we're roughly doubling the floor space available in our Thurso facility, and we expect to be putting additional equipment into that facility later this year and into next year. We're also expanding lab space in Burnaby, and we're retrofitting a building in Athens. We're already hiring people there, but the new office facility is still being renovated in Athens. So we've got lots of construction going on.
Perfect. So I hope that answers Doug's question. He didn't text back the specific of which location, so I guess you covered them all. When is a realistic timeline for scale up and significant revenue ramp? How long until mass commercialization for the 5G film, assuming that that's the first major market that you wanna go in? Ask William.
Okay, excellent question. We are a development stage company shifting into commercialization. That's why Meta thus far is not providing specific revenue guidance. I will comment on what it takes to get to volume production. We have the first Nanoweb line anywhere ever in the world using our proprietary RML technology operating in California today. We expect to have the half-meter web width second generation Nanoweb going into production in 2023. We've said that we expect to ship higher volumes to Sekisui in the second half of this year. Now, let me just say one more thing about volume production. We're already producing kilometers of material for our central bank customer. Now, its samples were not yet designed into that new currency, but it is by in any reasonable measure of volume already volume production. So we have in-house capability to produce very large quantities of nanoscale metamaterial films, and we believe that we're the leader in our category in that respect.
Great. And lastly, we know that with a very small amount of power, Nanoweb can be used in defogging and de-icing, and can be used in augmented reality and in reflecting 5G waves off of any surface and many other applications. We also know there is a level of chargeability with the metasolar film. Can you elaborate on how much energy this material can transfer to it? Or how much energy can Nanoweb essentially store with the aid of plasma fusion?
Okay, there's a lot to unpack in that question. Thank you very much. The first thing to observe is in trying to give a fulsome answer is that Nanoweb is a technology which can be tailored just by changing the recipe, the pattern, if you will, that's transferred by rolling mass lithography onto the film to do a number of different things. Within 5G, for example, we can produce a film that has conventional reflection, so that the incident angle of the signal matches the reflected angle, but we can tweak the pattern and make the reflection happen at a desired unusual angle, coming in almost vertically, going off almost to the side. That lets us route 5G signals around inside buildings, for instance, where signal propagation is bad. The transparent heating answer, I don't have at the tip of my tongue exactly what the power transfer is, but it's very efficient. It's both highly transparent and highly conductive because it has very low sheet resistance. That's why if we apply it to a windshield or a sensor for an EV, we can more efficiently clear the window or the sensor than systems that would transfer heat from something else like a heat pump or blowing hot air. As far as the solar application, just to remind people in the audience who may not be aware of how this works, what metamaterials do on solar cells is increase the angle within which the energy can be captured. If sunlight strikes a conventional solar panel too far off the 90-degree axis, then it bounces off instead of being absorbed. And what we do is add a layer to the top of the cell that helps low angle sunlight be captured and generate power instead of just a reflection. But I don't have, sorry, on the tip of my tongue exactly what that measurement would be.
And that obviously improve the total efficiency of the system, which is basically a big challenge in the solar
yeah,
panel.
it can be a replacement for tracking systems, mechanical tracking on ground-based systems where the panels are tilting east to west every day to follow the sun. That's a meaningful cost out of the installation. And of course, if you're talking about rooftop solar or solar on the wing of a plane or the roof of a car, you can't tilt that towards the sun. You need to catch whatever light you can at the angle where it sits.
Exactly. Perfect. So Rob, I think that it's 9:20 actually now, so time is up. I thank you very much for your presentation. That was very interesting. It's always great to follow the news of metamaterials and what you're doing. I think this is always positive news. So we're very happy to have you now with us. We thank you very much.
My pleasure. Vielen Dank alle für Ihre Aufmerksamkeit.
Wiedersehen und bis nächste Mal.
Wiedersehen.